Hi, so here we are. We're going to look at Lesson 1 in Unit 1, Functions and Transformations. We're going to start today by looking at three key concepts that will help us work with functions. First of all, what is a function? And then how do we describe the space that functions occupy on a grid? And we use domain and range to describe the space that the functions occupy on the grid. So let's look back at what a relation is. So a relation is a set of ordered pairs. Okay, so usually table of values, graph, an equation, or ordered pairs. And it's just defined as a pattern or relationship between two variables. A function is a special type of relation in the same way that an apple is a type of fruit. A function is a type of relation between two variables. Usually we say there's an input and then an output variable, in which each value of the input corresponds to no more than one value of the output. So the key here is that if I put in one input, I can't get two outputs. Okay? I can put in one input and get one output, but I can't put in one and get two outputs. We'll look at a couple of examples here with physics that might make a little more sense. Therefore, a relation is not a function if one x value has two or more different y values associated with it. So if you had a point like 2, 5, and then you had another point 2, 6, notice that that same x value has two different y values associated with it. And any relation that had those points, 2, 5, and 2, 6, sort of vertically piling on top of each other would not be considered a function. Could still be a relation, but not a function. I'm just going to sort of draw your eyes down here. I sketched in a little distance time graph here. And if you've done physics, you've probably looked at a lot of distance time graphs. If we imagine we're starting at time 0 and distance of 0, units away from our starting point, then when time starts to go and we start taking steps and we walk away from where we started and then we reach a point and we turn around and we start walking back to where we started, then our distance from home can sort of be visualized by this curve. So notice that this curve implies that, maybe at 2 or 3 seconds, maybe I'm, a meter away or 2 meters away or something like that. And then I get further away, but then, maybe at 4 or 5 seconds here, I'm same distance, 2 or 3 meters away as I was before. So notice the key feature here is that I can kind of keep hitting the same distances, once on my way up and once on my way back at different times. But that generally any one time corresponds to only one point on the curve. So each input has exactly one output, okay? And then this input has exactly one output, and so on and so on. So that can be visualized by the fact that one input, or one x value, or one time value, can be associated with one distance or one place, okay? Here, I could go to the same place, early in my journey, and then return to it again at another time in my journey. So notice these x values kind of represent time, and the y values are representing distance or place. So I could return to the same place at a later time. That's acceptable. We can do that in real life. Or I could just go to one place only one time and never go back. But here is the hallmark of what's not a function, and that is at one time trying to be in two places. Okay? So if we were to draw this sort of impossible graph, especially on a distance time, see what would happen. Okay, so there's time 0, distance 0, the time starts and we start walking away from our starting point and we start to go, wait a minute, now we're going backwards in time. Okay, so this is impossible. And then we repeat those same couple of seconds, but now in a different place. So this is probably the time traveler's paradox. And then we head off in this direction here. So notice that the implication with this crazy curve is that at some time we're capable of being in 1, 2, 3 different places. Okay, so the impossibility of being in 3 places at one time is like the fact that a relation is not a function. Okay, so imagine it this way, that you can't be in 2 places at one time. That will be not a function. You could be in one place at only one time and never go back. Or you could return to the same place at different times. These are both functions. These would describe something like this, okay? So it's not a function if the implication is that you can be in more than one place at one time. Functions are special because we know that for every x value, there is at most one and only one y value associated with it, okay? Whereas this thing is not a function. we don't know for sure if one x value could have 1, 2, 3, or even more y values associated with it. So a function is a special type of relation where the input and output have a one-to-one kind of relationship. Visually, on a graph, there's a really easy way, a really simple test that you can do to see if something is a function, and it's called the vertical line test. So when you draw a vertical line anywhere, a single vertical line anywhere where your relation is, if at any point it would cross over more than once on your curve, then it's not a function. Okay, so we can say that a relation will fail the vertical line test if the line intersects the graph at more than one point. So let's look at a few examples. This will make it a little clearer. If we have a parabola opening up, and here's our x-axis and our y-axis, then if I were to pick some spots and start drawing in vertical lines, any vertical line that I could draw would at most cross over our relation at one point. And so this makes it so that it passes the vertical line test. And if it passes the vertical line test, then the relation's a function. If we look at a sideways parabola, same thing. Here's our x and y axis. If it's possible to draw a vertical line and pass through more than one point, then we fail the vertical line test. Notice that if we were strategic, we could draw a vertical line that would pass through no points on the curve. And if we were really careful, we could draw a vertical line that passes through exactly 1 point on the curve. Okay? So it's not a matter of whether you could get 0 or 1. It's a matter of, is it possible at all to get through more than 1 point of intersection when drawing a vertical line? And if that's the case, then we fail the vertical line test. Okay, so this sideways opening parabola, not a function. A straight line, okay, so like this straight line with a slope, it's a negative slope, so the line is kind of pointing downwards as you go from left to right. Any vertical line we draw will pass through it only once, so that means that it is a function, it passes the vertical line test. A horizontal line would also pass the vertical line test, okay, so with slope of 0. But a vertical line would not pass the vertical line test because, in fact, if you were to draw a vertical line on top of your vertical line, then it would intersect at an infinite number of points. So that would be a big fail in terms of functions. Okay, so vertical line, not a function. Sine functions, okay, we're going to start graphing sine curves later on in the course. And sine curves are these curves that repeat over and over and over, these sinusoidal waves. A sine function, it's right in the name here, it is a function, again, because any vertical line would pass through the curve at most at one time. Okay, so this one is a function.